Hi everyone, I'm Dan. I'm the UK manager for Greener Power Solutions. So I wanted to look at a recent case that we just completed, a project that we finished, and we were tasked with powering some MRI and CT scanners for a hospital. So of course these bits of equipment require very large impact or inrush currents to start the scanning process. So this isn't dissimilar to a crane or an electric vehicle charger. Of course that's a lot of power when the car's charging, but then when the charge is finished it's no power.
None at all.
So these scanners are quite similar. Big impact roads, tower cranes are the same. Any big motorized loads such as hoists on a construction site, etc., all have these sort of transient moving loads that really make battery systems come into their own.
Yeah, old school triangle and startup.
Star Delta Motors, yeah, 100%. So yeah, we were approached with a problem. So the initial setup on site was one individual scanner. Now on the technical sheet for the scanner, it suggested that the inrush currents could be around 300 amps. So a 300 kVA diesel generator was specified to power the scanner. But there was also a 63 amp three-phase grid connection on the site, which you can see here. But initially that wasn't being used because the load required by the scanner, 300 amps, 63 amps, we're never going to get anywhere near it. So initially that was what was done. So Greener came in and we installed a battery system to hybridize that existing 300 kVA diesel generator. At the same time, a second scanner. So we now had two loads with potentials of up to 300 amp inrush currents. But by hybridizing the generator with the battery, we were able to provide the potential of 600 amps by utilizing the generator and battery together. Mm-hmm. Because, of course, we've got a battery capable of doing 400 amps and now a diesel generator that's capable of doing 350, 400 amps itself. So they had sufficient power available to drive the scanners, but also through the installation of the battery, we start collecting data. So all that data is being pushed up to the cloud and then displayed in Greener projects, as Robin was saying. So you can see the example load profile there. We'll go into a bit more detail on that shortly. But through this data, we were able to understand that the 63 amp three-phase power supply was actually sufficient to provide the energy required to run both scanners. So what did this mean? It meant that we could physically turn that generator off and remove it from site altogether, knowing that the 63 amp was sufficient to provide the energy, whilst the battery was still sufficient by itself to drive two scanners simultaneously. Yeah. So this ended up resulting in the generator being removed from the site.
Yeah, because the 63 amp connection will provide in a course of 24 hours over a megawatt hour of energy. So that's nearly 3 cycles of a battery.
So 3 charge cycles of a battery.
3 charge cycles of a battery.
Yeah,
just out of the wall.
It's often misunderstood quite how much physical energy you can harness from a very small grid connection, mm-hmm. which again, most people just disregard these small grid connections because they think my load requires this, that's not going to do it. But by utilising the battery system, it really shows what you can do to drive these large bits of kit mm-hmm. from very small power supplies. So that would be what we call peak shaving. So we have a small power grid connection coming in, and then we, again, as Robin explained, stacking the inverter on top of or in parallel with that, which then means we have the peak power available to come in. Also through the data gathered, you can see here, this was a week's worth of data from both scanners running simultaneously. And although it is exceeding the 63 amp mark, it never goes anywhere near the potential 600 that we were initially tasked with.
Yeah, you can see here that the load in the downside is 30 amps, and then on the
so the daytime operation
goes over 90.
Over 100 odd amps there. But because that nighttime load is 30, whatever energy was used from the battery to drive the scanners during the day, of course, whilst the load is over that 63 amp mark, the battery is depleting. Mm-hmm. But because the nighttime base load set at 30, we had the remaining 33 amps to exact to recharge the battery so that the battery was fully charged for the following day. So really the results were that we started with the hybrid solution, gathered the data, and from the initial setup, just by hybridizing the generator, still leaving the generator as the charging source for the battery, we reduced the generator run hours by 87%, which resulted in a 56% fuel reduction and a obviously related emission reduction on site. And then eventually we moved to the peak shaving setup, which eradicated the requirement for any diesel to be used on the site whatsoever.
And every litre diesel is what? £1.50 nowadays? What is it?
Yeah, something like that. It changes. Yeah. Yeah, so that concludes the first case.